And in this particular topic, we are looking at exponents and surds. We'll do a recap. We'll look at the rational exponents. We will look at exponential equations. We'll look at surds and surds equations. Let's recap some laws of exponents and rules for that matter. We will remember that any number exponent 0, a exponent 0 in this particular instant, any number to the exponent of 0 is equal to 1. We will remember also that when you have a exponent n times a exponent m, when the bases are the same and you are multiplying your powers, when the bases are the same and you are multiplying your powers, what do? You add your exponents. So a exponent n times a exponent m is equals to a exponent m plus n, or n plus m, regardless how you want to put it. Also, we must also remember that a exponent m all goes to exponent n. What we do, we distribute your exponents such that it will be a exponent m times n. That's why it's a exponent mn. And also when you've got two bases that are not the same, a times b, all exponent n, you can now distribute the exponent to each base such that you have a exponent n multiplied by b exponent n. And of course, when we are dividing powers of the same base, we subtract your exponents. That's why we are having a to the n divided by a to the m is equals to a to the n minus m. And also, when you have a quotient, a over b to one exponent, you distribute that exponent to the numerator and the denominator thereof. We have to practice lots and lots of these laws. Very important. Pay attention that 2a is equal to a plus a, but it is also equal to 2 times a. You must pay attention to that. But a squared is equals to a times a. So you need to know the difference between the division, or rather the multiplication and the addition when it comes to exponents. Also the division and the subtraction, you do have to know about that. Also, you must remember that the distribution in terms of binomials, we call this a perfect square. You remember a perfect square, how you distribute it such that you have a squared plus 2ab plus b squared is equals to into a plus b close all squared. You'll remember that. It is not, and I know many students would make that mistake and think that a into a plus b all squared is equals to a squared plus b squared. That would be wrong. That would be incorrect. Also, you need to remember the issue of negative exponents such that a to the minus n all over b is equals to 1 over a to the n b. Also, it's very important to also remember that a all divided by b to the minus n, and then you can play around that. So there are many negative exponents that you really need to recap and remember. Let us look into prime numbers only have two factors. Prime numbers only have two factors. What do I mean? Prime numbers is a number that it can only be divided by 1 and itself. That is a prime number. It's a number that can be divided by 1 and itself. It has only two factors, that is 1 and the number itself. And these are just some few examples of those prime numbers. Now, I must just say, okay, fine, let us work around, let us get this 75 exponent x to prime, our bases such that are prime factors. That would be 3 multiplied by 5 squared, because 3 times 25 is 75. But what is 25? 25 is 5 squared. And hence, when you use the laws of exponents, you can distribute that to 3 exponent x multiplied by 5 exponent 2x. For example, if you have to simplify that one using prime basis. Having to simplify that one using prime basis, you know that 27 is 3 times 3 times 3, meaning 27 is the same as 3 cubed. And then that 3 cubed, you use one of the laws of exponents to say 3 exponent 3, and then you know that the 3 multiplies the n minus 1 outside of that particular bracket as an exponent. It distributes such that it becomes 3 exponent 3n minus 3. Let us rather factorize the following. You would remember how to factorize, and we normally use this when we are solving for x, but we'll get more into that, where you've got 5 to the x minus 5 to the x plus 2. You have 5 to the x minus 5 to the x times 5 to the 2, and then you take a common factor. The common factor is 5 to the x, such that you'll be left with open bracket 1 minus 5 squared, or 5 to the 2 for that matter. And because you took out, of course, your common factor. And then what do? Then you know that 1 minus 25 is minus 24, and therefore your answer is minus 24 multiplied by 5 to the x. Let's look into that one. That one is a difference of two squares. If you look at it, it's a difference of two squares where you have 2 to the 2x minus 3 to the 4x is equals to, and then if you factorize it as a difference of two squares, you'll have a 2 and 2 to the x minus 3 to the 2x, and then on the other bracket you'll have 2 to the x plus 3 to the 2x. So this is a difference of two squares. And that is why then that is factorized. There are many other ones that I would love you to simplify. Of course, you need to apply the laws and rules of exponents thereof. You look into that, you are definitely going to apply the rules and the laws of exponents. Try that out and let's see how far you go. Let's see how far you go. That is a beautiful one. This number 5 is very examinable. You know for a fact at number 5 that 15, you can break it to prime basis. That is going to be 3 and 5. And the 4, you break it to prime basis. That is 2 squared. And the 9, you break it to 3 squared rather. And the 25, you'll remember from previous your other previous problems, it was 5 squared. And then the 16 will be 4 squared. Of course, you break it down and then you use the laws of exponents. And you can go further and further, simplify and do all that you have to do. It is also important to understand the rational law of exponents, or the rational exponents rather, where you have a is equals to m over n is the same as root n over, or root n a exponent root n a exponent m, where the n is an element of natural numbers and the n is m is an the m for that matter, not the n is an element of natural numbers and the m is an element of integers, and the a is greater than 1, greater than, meaning it's positive. Let's look into that. What do we mean? We mean that is equal to the x 1 over 2 is the same as 2. The x exponent 1 over 2 is the same as the square root of x. And that is true. Also, the sets, or rather the rational exponents, we also call them the sets. That's the other name for rational exponents. That is why that 9x exponent 1 over 2 is the square root of 9, and 8 exponent 1 over 3 is the cube root of 8. And the square root of 9 is 3, and the cube root of 8 is 2. 3 plus 2, that should give you 5. So here we're changing to roots, but there comes a time when others have to be changed to prime factors. Changing to prime factors, so there are many ways to approach this particular problem. You can either change your exponents to roots, or you can change your bases to prime factors. I always say try to change to prime factors first, unless stated otherwise. East or west, home is the best. How you work with rational exponents. I do want you to also try to approach these particular questions. They will be helping you a lot in terms of your understanding of exponents. Please follow the rules. Please follow the principles. Exponential equations, that's when you solve for x. If you look here, all we are doing, we are saying we have 2 exponent 1 over 4 equals to 8. Number one, we are solving for x, so we'll definitely want to get rid of the 2 in front of the x. We divide both sides by 2. We'll have x to x to 1 over 4, and then on the other side, 8 divided by 2 gives you a 4. In this particular instance, we will therefore say, okay, fine, let's get our right hand side in terms of prime basis. And you have 2 squared, and then that is when you do prime factorization, prime basis. And what you can do, you can just make sure you put quad on both sides. Put the exponent of 4 just to get rid of the exponent 1 over 4 on the left hand side. That would then give you a situation whereby you've got x is equal to 2 exponent 8, and that should give you x is equals to 256. There can be many other type of equations that we can give you. Many other type of equations that we can give you. If we can give you this equation, you'll realize that is x plus 3x exponent 1 over 2 minus 10 equals to 0. In this particular instant, you can decide to say, okay, fine, how do I make sure that I factorize this? You can now introduce 1 or an exponent of 1. But how do you introduce that exponent of 1? You introduce it by saying x, that x which has an exponent of 1 there, you say it's actually exponent 1 over 2 close x multiplied by 2. You've just introduced the exponent of 1 but in a different form. And then you can realize it's a trinomial. You can factorize it to 2 binomials, and that is how you factorize it in terms of not really a difference of 2 squares, but just binomials. You factorize it and you realize that's what it gives you. Thereof, you can solve for x using your laws of exponents. The other one, x is no solution. You can see that x, the square root of when the square root of x equals to minus 5 has no solution, but the square root of x equals to 2 actually tells you that the x is 4. When the square root of x is equals to 2, it actually tells you that x is 4. Why am I saying the square root? Because the exponent there is 1 over 2, and you know when it's 1 over 2, it's actually the square root of x. And then you can play around that particular exercise again and again. I want you to play around these exercises. I do want you to play around them. The sets which we have already introduced, there's square root, which we don't even put the 2 there. It's a gentleman's agreement. And there's a cube root, there's a fourth root, there's an nth root, there's an whatever root. So we even call, we go so far up until we say the nth root. So the nth root of a multiplied by the nth root of b is equals to the nth root of a times b. So the product of the sets is the sets of the product. The product of the sets is the set of the product. And the quotient, the set of the quotient is the quotient of the set, and that is also true. I want you to pay attention that the nth root of a times b is equal to the nth root of a times the nth root of b, and I want you to be careful that the nth root of a divided by b is the nth root of a divided by the nth root of b. So the which is what we just said, that the nth root of the product is the product of the nth roots, or rather the nth root of the quotient is the quotient of the nth roots. But we must be careful that when it comes to addition and subtraction, that is not the case. Be careful of that. Be careful of this. Also, you must understand that at times you need to work with sets when you are working with numbers. Break numbers down into squares and cubes. Make sure all the time when you work with sets, break the numbers down into squares and cubes. You've got your square numbers, you've got your cube numbers. You know that. Let's look into example. If you have that, you realize that the fourth root of that, if you break it, it will give you that. So this should have been done in grade 9, something like that. So you do have to have a lot of practice when it comes to sets. You do need a lot and lots and lots of practice when it comes to sets. I mean, look into that, the square root of 9 times 25. Looking at that law of sets, that the nth root of the nth root of the product is the product of the nth root. That's why you have square root of 9 multiplied by square root of 25, and then we do know what is the square root of 9. Of course, that is why our answer is 15 at the end of the day, because 3 times 5 is 15. But that is something different, because we did say beware, that is not the same. There are what we call pure sets, where we have to factorize them into perfect squares, such that we know 50 is the same as 25 times 2. We must make sure we factorize them to perfect squares. We know that 18 is the same as 9 times 2. So you should be able to split them thereafter, and then you know what is the square root of 25. And then, of course, you do know what is the square root of 9. That is the 3. And that is why 5 root 2 minus 3 root 2. 5 oranges minus 3 oranges is 2 oranges. That's why the answer is 2 root 2. That is how you work with sets. Look at that beautiful. This is an examinable question. Very beautiful examinable question in question 1. Even in grade 12, question 1, mathematics, paper 1. Very examinable. Should be able to break down your bases into prime factors, and then thereafter you split your sets, and you are home and try. Simplify further. Make sure that you are able to play around this. There's an exercise that I would love you to deal with. I think you'll like this. You must also be able to arrange do some comparisons, arrange things in ascending order, you'll understand that is the same as, you can introduce 1 in a nice manner such that you realize that this is the same as 4 exponent 1 over 6. Actually, not arrange into ascending order, into descending order for that matter. Can you see how beautiful that can be arranged? All to the exponent 1 over 6. So you know that in descending order, how do they work? You saw you have the 2. Why am I saying that? I'm saying in descending order, you start with the 3, because that's the one that becomes more smaller, and then the 2 root 3 is greater, for that matter. 2 root 3 is greater than 6 root 8 is greater than 3 root 2. The issue of rationalizing denominators is very important. To get rid of the set in the denominator, you multiply by the denominator itself. You just multiply by 1. That is that. You just multiply by 1. So you multiply by the denominator itself. That is how you rationalize the denominator. So you must check your answers. When you deal with sets, please check your answers. Check your solutions. For example, how do you check your solutions? You check because you found 12 and minus 2. Check if it's 12, if the left-hand side is equal to the right-hand side. If that's the case, that's correct. If x is minus 2, is the left-hand side equal to the right-hand side? No. So x is only equals to 12. 12 is the only solution because the 2 does not give such that the left-hand side is equals to the right-hand side. And then you can play around this, and then once after you do that, then you are home and try. Goodbye.